arithmetic sequences. The word arithmetic just means that you're always adding a constant to get to the next term, and a sequence is just a list of numbers. So that's what arithmetic sequence means. There's a formula we're going to use. It's a little different from the book, but I think it's going to be easier to understand. And it is this. This is the formula, okay? If you want to write a rule for the nth term, and I'm going to label each of these, you basically find the 0th term, a sub 0, and then you add the term number times that common difference, which is that number that you're adding every time. So let me label all these. In the equation, this stands for the nth term. That's why it's a sub n, nth term. And this n stands for the term number. Those things you don't even have to find. You leave those alone. That's the term number. Like if I want the 5th, yeah, you just leave those alone. The things that you need to find for the equation are these that I'll label here. You need to find the 0th term, which is, depends on how hard it depends on the problem how hard that is. You have to find the 0th term, and then you have to figure out what that common difference is that you're adding each time. It's known as a difference because you can find it by subtracting any two consecutive terms. But we use D because it's like the common difference. So that is the whole equation. Now the thing, you'll see something slightly different in the book, but this I think is easier to use. So let's do 3 examples of doing this in different situations. So the first example, the directions will say this: write the rule for the nth term. For the nth term. And once we know the rule, we could find any term that we want. We could just plug it into the formula or the rule once we find it. So the first example, we'll start with something where things are made easy for us. So 17, 15, 13, 11. This is something I'm going to quiz you on that I want us to all get 97% of us to get right again. Okay. So what we need to find the rule is the 0th term and the common difference. All right. So what's the common difference?
2.
Yeah. Yeah. So we add -2 each time, right? So that's the common. Yeah, we're subtracting 2 each time, or adding -2. So D is -2. And what's the 0th term? If we were to go in the reverse direction, then instead of subtracting 2, we need to add 2. So what is the 0th term then is 19. All right, so we're ready to write our answer. We can directly write it. So if we want a formula for the nth term, a sub n, we would just write 19, the 0th term, minus 2n, because we're subtracting 2 each time. Now let's just check it out. Let's say, so I'm going to box it because that's my answer. Now let's say I just wanted to know the 10th term or something. So if I wanted to find, it would be labeled a sub 10 for the 10th term. I would just plug 10 in for n. So a sub 10 equals 19 minus 2 times 10. You literally plug it into the formula. So that's 19 minus 20, which is -1. Nice. That would be the, if it asks, you could find any term, right? Just by using that rule, you just plug it right in. And that's the first example. Any questions on that? Okay, let's see if it's phrased differently. Let's make it a little more challenging here. So let's try this example. Let's say we have the 11th, this is a whole different problem, okay? I'm going to tell you that the 11th term is -57. Okay, the 11th term in the sequence is -57. And I'm going to tell you that the common difference is -7. So I'm adding negative 7 each time. Okay, and we need to find the formula. So, same as before, you need to find the 0th term and the common difference. Do we know the common difference? Yeah, it's sitting right there. So all we need to do, our goal is to find the 0th term. So how do you think we would do that? We just gotta work backwards, right? So so let's say, so we know negative 57 is the 11th term. So what's the 10th term? How do we work backward? What would come before that? To work backward, you have to do the opposite. So you got to add 7, right? You got to add 7 to go the other way. So if you add 7 to this, you get negative 50, and then to find the 9th term. Yeah. Now we don't want to keep doing this. So what's the faster way to do that? Yeah. So how many times do we need to do this to get to the 0th term? 11, exactly. So the shortcut, so we want a sub 0. So you basically add 7 11 times. Add 7 11 times. So I'm going to do negative 57 plus 7 11 times, right? Multiplication is repeated addition. And I want to add the 7 11 times, so that's so much faster than writing it out. So on your calculator or in your head, you would get 20, and we're ready for our formula. Then the nth term, a sub n equals the 0th term, which we just found is 20. And what's the rest of the formula? Minus 7n, exactly. Minus 7n. And so now we could use that formula to find whatever we're interested in. So you might see, so far you might get a problem where they give you the sequence, the start of it. You might get a problem where they give you a term and the difference. And then the last kind of problem is where they give you 2 terms. And let me show you how to do that. So let's say you have, I'm going to tell you, this is a different problem now. The 7th term is 26, and the 16th term is 71. You saw this in your activity in your worksheet last time.
So where did you get the 20 from?
Where did the 20 come from here? That's the 0th term, because if I repeated this process, because I wanted to move backward, right? I was trying to move backward to find the 0th term. The 11th term is that. So I had to add 7 11 times to get to the 0th term. So I did negative 57, and then I added 7 11 times. Yeah, that equals 20. Yeah, that equals 20. Okay, so we're on the last one here. I'm going to tell you 2 terms, and you got to find the equation. So the cool thing about this is it's related to Unit 1 on linear. It's a linear function because it changes by the same amount every time. That's basically the slope of a line. So you use the formula for slope. Let me let you picture it this way. So I'm going to put a little star here. It's like the common difference is like finding the slope. And remember, that was like you subtract the y's and you subtract the x's and you get the slope. So like visually, if you were to picture this, you could graph the point. If you know the 7th term is 26, it's like saying you're graphing the point 7, 26. So you could picture a point here at like 7, 26, and I'm not doing the scaling, but and then here is like 16, 71. So the term numbers are the x coordinates. You want to go from 7 to 16, and the actual term changes over that period of time from 26 to 71. And you want to figure out by how much is it changing each time. So literally, the common difference you use the slope, y minus y over x minus x. So this is great review, and you're connecting it to other things. So 71 minus 26 over 16 minus 7. That's how you find the common difference. You take the terms, subtract them, and then you take the term numbers and you subtract them. And so you get 45 over 9 if you just do the arithmetic. No pun intended. And 5 is that common difference. That's, if you add 5, if you keep adding 5, 9 times, you'll go from 26 to 71. And I could write out the terms of that sequence. So, I know the common difference. How do I find the 0th term? Because I still need that. Exactly. Yeah. So let's work backward from the smaller one. Let's go from the 7th term and work backward to the 0th term. So all you do is take 26, and we want to go the opposite way. So we're gonna subtract 5 instead of adding 5. How many times? 7 times, exactly. Everyone see that? To go from the 7th term to the 0th term, we want to go backward in time. So we do the opposite of 5. We subtract 5 7 times. It's basically the term number. So you do the arithmetic. 26 minus 35 is -9. And our formula for the nth term, which you might see written as t sub n, it's either a sub n or t sub n, it means the same thing, is -9, our 0th term, plus 5 times n. And we can now use that formula to find any term that we want.